Hello everyone. In this video I'm going to speak about the coordinate covalent bond. Let's get started. The coordinate covalent bond or the dative covalent bond is a covalent bond in which both electrons come from the same atom. So we have two very important features in the dative covalent bond. We have a donor and we have an acceptor. What is the donor? The donor is the atom that has a lone pair of electrons. It's usually the central atom. Then we have another atom or ion that would accept those electrons, and it is called an acceptor. Why it would accept? Because it is an electron deficit. We have three important examples here, which are ammonium ion, hydronium ion, and carbon monoxide. So as you can see here, the product or the species that has a dative covalent bond could be ion or a neutral molecule. Okay, let's see how the ammonium ion will be formed. Ammonium ion, first of all, ammonium ion is normal ammonia plus hydrogen ion. It would make this NH4+. So what is happening? We have nitrogen, which is linked to 3 hydrogens. When nitrogen is linked to 3 hydrogens to make ammonia, it has a lone pair. This lone pair could be donated to a hydrogen ion, because hydrogen ion here is electron deficit. So we have here the nitrogen is acting as a donor, while hydrogen ion here is act as an acceptor. Okay, is it possible to draw it like that? It is better to draw the ion as the following. So we have here nitrogen, we have here the hydrogen. You can draw the dative covalent bond as a normal line like that, or an arrow. Then we have hydrogen, third, fourth hydrogen, then this is the ion, NH4+. It's much better to draw it like that. Next example we have here, we have H2O plus H+, and this would make H3O+, hydronium ion. So it's a normal water molecule that has two lone pairs, because oxygen has 6 electrons in the last shell. Very important to remember that. Oxygen, you don't have to remember that. It's always given the periodic table that oxygen group 16, so it has 6 electrons in the last shell. If it's making 2 bonds, so it has 4 electrons in the last shell, which are making 2 lone pairs. This lone pair could be donated to a hydrogen ion, and the result will be hydronium ion. So we have oxygen linked to hydrogen, another hydrogen, we have a lone pair, and we have to put the brackets. It's very important to show that this is an ion. Can I leave the bond like that? You can do that, or you can make this arrow. Okay, let's see carbon monoxide. Carbon monoxide is different because it's not an ion. So what is happening here is we have normal carbon and an oxygen. Carbon has 6 electrons, so it's 2, 4. It has 4 valence electrons. Oxygen has 6 valence electrons. So oxygen would make a double bond with carbon, but here carbon, so as you can see here, carbon has a lone pair. Carbon will never be satisfied until it share, or until it gain 4 electrons, which we shouldn't say gain because it's not a gain and loss here, but until it share 4 electrons with another atom. So what is happening here to make this carbon satisfied? One of the lone pairs, this lone pair or this lone pair, will be donated to the carbon in the form of a dative covalent bond. So it will be like that. Carbon still has its lone pair, 2 normal covalent bonds. Then we have here a dative covalent bond. Oxygen has its lone pair. We have here oxygen here is a donor. Why it's a donor? Because it donated lone pair of electrons. You don't have to say that oxygen will lose 2 electrons because it's not an ionic bond. It's still a covalent bond. It's still covalent bond. So it's just donating 2 electrons or a lone pair to carbon because carbon would need them. And the carbon here is an acceptor. Okay, so as you can see here in our 3 examples, we have an acceptor and we have a donor. Oxygen here is a donor because it has lone pairs of electrons, and we have an acceptor. The acceptor is always electron deficit, while the donor always have a lone pair of electrons.